Hi everyone, welcome to another video of NS Pharma. Today we will discuss important multiple choice questions from Pharmaceutics 1, chapter number 6 and chapter number 7, that is size separation, and chapter number 7, that is mixing and homogenization. These two chapters we will see in this video. Important multiple choice questions as well as some important points regarding this chapter. So we can start the first question. The sieve through which 40% of the particle should pass in case of coarse powder. Sieve through which 40% of the particle should pass in case of coarse powder. The question was based on the coarse powder. So options are 10, 60, 22, 44. The correct answer, I think everyone know this thing. Option D, 44. If you don't know, I will give after the second question some details regarding the coarse powder and fine powder. We will see the second question first of all. Sieve through which all the particle must pass in case of moderately fine powder. Options are 44, 85, 22, 10. Sieve through which all particle must pass in case of moderately fine powder. That is option A, 44 is the correct answer. Powders are actually classified into 5 types. Mainly they are classified into 5 types. One is coarse powder. Second category, moderately coarse. Depend upon the size. You can see coarse is comparatively bigger. Moderately coarse means comparatively less in size. Moderately coarse. Third option is moderately fine, is smaller than this category. Moderately fine. Then comes fine. Fine is smaller than moderately fine. Then the last category, that is first, second, third, fourth and fifth. Very fine. Very fine is the smallest one. Very fine. Like these 5 categories are there. For the powders, they are classified based on the size. So how they are classified? Because based on their size, we will decide the size when we passes these powders through the sieves. Then only we will get the different sizes. So here, in case of coarse powder, all the particle inside the sieve, in all the particle of coarse powder should pass through sieve number 10. Sieve number 10. All the particles should pass. And 40% of the particle should pass through sieve number 44. I hope you understood. That is 40% of the coarse powder. That means one powder, we have one powder, we got one powder and said that it is coarse. For proving that one, we should pass this coarse powder, the powder that we got, through the sieve number 10. So that all the particles from this powder should go through that sieve number, through that sieve, and also we should pass that same powder through sieve number 44. Minimum 40% of the powder should pass through that one. Now hope you understood. This is what you mean by sieve number is, it's actually indicate the mesh length in case of sieve of a 2.5 centimeter in each direction. As depend upon the aperture, that is sieve size, aperture size, we can 10 means 10 aperture will be there within that area. 44 means 44 aperture, that is means 4 small holes will be there inside that area. So if there is a 44 holes, definitely in the same area that will be smaller. 10 means comparatively bigger size, 4. So in case of a course, all the particles should pass through 10 sieve number 10, and in case of course 40% of the particle should pass through course sieve number 44. We will move to the next part, moderately coarse. In case of moderately coarse, this is 22. All the particles should move through the sieve number 22, and 40% should pass through sieve number 60. In case of moderately fine, the question was that 44, all the particles should pass through 44, and here it is 85. 40% should be passed through 85. In case of fine, there is no upper limit. That means I am saying about this, there is no 40%. It should all should pass minimum through 85. All should pass through 85. And in case of very fine, 120. All the particles should move through 120. Sieve number 120. This is the category. This is very important. Very important. Almost all the question paper have this question, so you have to study this very well for getting more idea. This one, you know, this is 5 categories are there: coarse, then it's come smaller one, moderately coarse, then comparatively more smaller, moderately fine, then again smaller fine, then the last there is very fine. Here you can see the difference. In case of this one, almost 20 difference will be there. 10, 22, that means 10, there is a 10 difference, and then it is 22 to 44, there is a 10 to 22, there is a 12 difference, that is almost 10. You can see almost 10, and 22 to 44, there is 22 difference, that is you can say it's 20. Then it's come 44 to 85, there is a 41, that is you can mind it as 40. Then 85 to 120, like that. Here you can see there is almost a difference of 20, 44, 60, 85. I am not accurately, I am just saying for getting more idea, means no need to, you know, change the value for that one. I am just saying for remind. We will move to the next question. Otherwise you have to study by heart these numbers. That will be more better. Okay. We will move to the next question. Question number 3. All the particle passes through sieve number 44, and 40% of the particle is passing through sieve number 85. Then the grade of powder is. This is from the same question. You can see here. All the particle is moving through sieve number 44, and 40% of the particle moving through 85. You can see here. All the particle is moving through 44, and 40% is moving through 85. That means it's coming under moderately fine. We can see here in the option moderately fine powder. Next question, question number 4. In size separation using sieving method. Size separations are different methods are there. Sieving method is there, then cyclone separator is there, then air separator is there. Like that, different methods are there. This is one of the methods, sieving method. In size separation using sieving method, sieves are arranged in sieving method, sieves are arranged in ascending order, descending order, any order. Sieves are of larger size at the bottom. This is not sails, this is sieves. So ascending order means smaller size. Sieves of smaller size will be in the top, and when you are coming in the bottom, sieves of larger size will come. But in the descending order, larger size of the sieve will be here, and the smaller size will come here in the least in the bottom, like that. So the correct answer is descending order. Sieving method, sieves are arranged in descending order. That means sieves of larger size at the top. Sieves of larger size at the top. Larger size sieve, larger sieves. Top. When we are going to the bottom, the size of the sieves will become smaller. We will move to the next question, question number 5. The principle behind cyclone separator. cyclone separator. The principle behind the cyclone separator. This is also another method for size separation. Options are agitation, centrifugal force, then brushing, all of the above. The correct answer is centrifugal force. Centrifugal force. Cyclone separator is working on the basis of centrifugal force. Next question number 6. Which of the following size separator is connected with the ball mill? Ball mill we already studied in the size reduction chapter. Ball mill, the principle behind ball mill is attrition and impact. Fluid energy mill is also coming under the same category, that means attrition and impact. So here, which of the size separator is connected with the ball mill? Elutriator, air separator, cyclone separator, then sieves. The correct answer is air separator. Air separator are normally connected with the ball mill or hammer mill, even a hammer mill also. For what? Actually to separate and reduce the particle size. Actually in this one, air separator, in case of air separator, it will be working on the basis of centrifugal method, same method as like a cyclone separator. So here there's a small difference. In air separator, the picture will be like this. Here it will go. Here we will give the feed inlet, means what are the powders that has to be separated, what are the mixer we have to separate here, and here will be one motor. That motor is connected with one disc as well as one blade. Disc will be there and blade will be there. This is giving air actually. Okay, there is a centrifugal force will come, like when something is rotating, the total air from inside the chamber also it will rotate, so the separation will take place and the fine particle will come here. Fine particle, that fine particle will come here, and comparatively denser particle, that will, there is one another like this. Here is another outlet. This is for comparatively heavier, that means more denser particles. It will come here. This is directly connected with the ball mill, and this ball mill, and what we will do, reduce the size, and it will give us a feed, so that we will get more fine powders, fine particle. This is what here air separator is doing. But in case of cyclone separator, there is no feed, is not like this. Feed is given through air inlet, that through this way it will be mixed with air, and it will be at a given higher velocity. There is no motor. It's a motor actually in the air separator. In a cyclone separator there will not be motor. So cyclone, there is a high velocity air is given through this one, through inlet. After that it will go like the this centrifugal force, it will come. So the lighter particle will go through the outlet, means it will outlet will be like this outlet for a lighter particle. Then here it will be for heavier particle, that is solids. For solid will come here. Next we will move to the next question number 7. In cyclone separator, the powder is separated depending on its, in cyclone separator, the powder is separated depending on its particle size, density, particle size and density, shape of the powder. Correct answer is option C, particle size and density. We will move to the next question number 8. In negative mixture, this is the next chapter, that is chapter 7. Until now we studied chapter number 6. Now we are moving to chapter number 7. The first question of the chapter number 7 is, in negative mixture, this we should know what is negative mixture, what is positive mixture, and what is neutral mixtures. We will study first of all the question. After that we will see what are different mixtures, type of mixtures. In negative mixture, two miscible liquids are mixed. Two immiscible liquids are mixed. Soluble solid is dissolved in water. All of the above. Correct answer is two immiscible liquids are mixed. That is negative mixture. So mixtures are classified into three types. One is positive. Okay. Another one is negative. And the last one is neutral. Like this, three type is there. In case of positive mixture, two miscible liquids are mixed. Here it is the first option. Two miscible liquids are mixed, or soluble solids are dissolved in water. So we can say that suppose sodium chloride. When we are adding sodium chloride in the water, it will be soluble. So that is the positive mixture. Or two miscible liquids which are already mixable, when you are adding it automatically will be miscible. That is also coming under positive mixture. Otherwise soluble solids dissolved in water, that is positive mixture. That we cannot reverse, that is irreversible, that we cannot take it back. That means if suppose we add salt in the water, okay, salt in the water, this salt will be dissolved in the water. We cannot take the salt back. We cannot separate salt and water afterwards. That means irreversible. They are irreversible. But in case of suppose negative mixture is not like that. In the option itself, one is two immiscible liquids. They are not miscible. Immiscible liquids are mixed in case of negative mixture. Or insoluble solids are mixed with water. They form negative mixture. They are reversible in nature. But in case of neutral, they are static. That means the substances do not have any tendency to mix. These substances, they don't have any tendency to mix with each other. But once it is mixed, they cannot separate after mixing. So the properties of positive mixture as well as negative. They can mix each other, but they are normally not mixing. They don't like to mix. They don't have any tendency to mix. But once it is mixed, they do not separate after mixing. That means irreversible. Understood? They will not mix each other, but once it is mixed, they will go to irreversible state. They cannot separate each other. That is neutral class. So these are the three different classes, positive, these three different types of mixtures, positive, negative and neutral. So in the question, negative mixture was there. So option 2, immiscible liquids are mixed. That is the correct answer. We will move to the next question, question number 9. Which of the following is wrong? Option A, it is easy to mix two powders having same particle size. That is correct. We can easily mix two powders having same particle size. If it is different particle size, it is difficult comparatively. Next option, it is easy to mix powders having different shape. See, it is difficult to mix two powders having different density. That is also correct. The same density will be more preferable. Option D, two powders can be mixed effectively if it is taken in an equal proportion. That is also correct answer. The wrong answer is option B. Means which is the wrong statement? The wrong statement is option B, and the correct answer is option B here. It is easy to mix powders having different shape. No, actually, the ideal particle shape for the mixing, for uniform mixing, is spherical shape. So different shape is not preferable. Spherical shape is more preferable. Okay. Now we will move to the next question. Question number 10. Which of the following can be used for mixing powders? Which of the following can be used for mixing powders? Tumbler, double cone blender, air mixer, all of the above. The correct answer is all of the above. Tumbler, double cone blender, air mixer, all can be used for the mixing of powders. This one you have to note that there is a different type of mixing. We are studying different type of mixing. The question was based on powders, so we have go for all of the above. Suppose in the next question, question number 11, paddle mixer. paddle mixer is used for mixing. So maybe the question will come like air mixer is used for the mixing. At that time you have to select powders. So here in the question was paddle mixer is used for mixing. Correct answer is liquids. So for the what are the equipments used for mixing of powders? First of all, we will see the powder mixing. One is tumbler mixer, another one is double cone blender mixer, then air mixer, then agitated powder mixer. These are the different type of mixers. Next one for the liquids. Here we said it, paddle mixer is used for mixing liquids. So another equipment for mixing of liquids are propeller mixer. Propeller mixer is very important. Propeller mixer, different questions are coming from a propeller mixer. Then turbine mixer. Turbine mixer. These both and this one paddle mixer is also used for mixing of liquids. So the next question we are moving to. Before that we will study semi-solids also. In case of semi-solids mixing, we are using different technique, that is mixers. One is triple roller mill. Triple roller mill is very important. It's used for the preparation of ointment base. Useful for the purpose of mixing of solid powders in ointment base. This is most of the questions. This is important question. Most of the pharmacy previous year exam papers have this question for the preparation for the mixing of solid powders in ointment base. Which of the following machine is used? Which of the following mixing machine is used? Here it is, triple roller mill is the correct answer. So one of the mixers for semi-solid is triple roller mill. Next one, agitator mixer. Agitator mixer. Now the last one, planetary mixer. Planetary mixer. Agitator mixer, planetary mixer. These are the different types for the mixing of semi-solid. We will move to the next question. Question number 12 is based on the propeller mixer. Maximum speed of propeller mixer. Options are 8000 revolution per minute, 5000 rpm, 12,000 rpm, and the last option 100 rpm. The correct answer is 8000 rpm. Correct answer is 8000 rpm. Next question, question number 13. Vortex formation is a disadvantage of which of the following? Vortex formation. This is also important question. Vortex formation is a disadvantage of which of the following? Options are propeller, carbon mixer, paddle mixer, turbine mixer. The correct answer is propeller mixer. Propeller mixer is the correct answer. These are the different multiple choice question from this chapter, but we will see some important another topic, that is viscosity. In case of viscosity, different methods, different for finding out the viscosity, different machines are used, different instruments are used. This is also important thing we will study here for finding out the viscosity. Viscosity means a resistance to the flow. That is called viscosity. Okay, so for finding out the viscosity, one is Ostwald viscometer. Ostwald viscometer, one device. Okay, the next one is Rudwood viscometer. Rudwood viscometer, and the third one is falling sphere viscometer. Falling sphere viscometer. This name came from their Ostwald, Rudwood, falling sphere. That depend upon the method as well as the scientist. So the last one, cone and plate viscometer. These are the different type of viscometers used for finding out the viscosity of a fluid. So in case of Ostwald viscometer, there is a formula for finding out the viscosity of a unknown liquid. Here it is the equation for finding out, is equal to d1 T1 divided by d2 T2 into N2. So here this is the viscosity of unknown liquid. It's called viscosity of unknown liquid. For finding out the viscosity of an unknown liquid, this is the viscosity of unknown liquid. D1 is the density of unknown liquid. T is the time to fall down. That says 1 mark is there in that instrument. There's no need to study this whole thing. This is not a subjective type of questions. This is mainly using for the objective type questions. So if you are preparing for the subjective questions, this is not enough. You had to draw that picture and all this thing. Ostwald viscometer, there is a different mark is there inside that capillary tube and all this thing. You had to mark that all the items. Here right now I am saying regarding the objective type question. In that objective type question, it will not come like that. It will ask for the equation maybe. So for that only I am right now giving. So this is viscosity of unknown liquid. This is D1. T1 means D1 is density of unknown liquid. T1 is the time of fall, time taken to fall down for the unknown liquid. D2 is the density of non-liquid. T2 is the time to fall of the non-liquid. N2 is the viscosity of non-liquid. Okay. Now the other one is one important thing is unit of viscosity. What is the unit of viscosity? It's actually according to SI unit Newton second. SI unit, I am saying about the SI unit Newton. I think this video is a little bit longer comparative to other chapters, but all are important things you have to study. That is the Newton second centimeter per centimeter square. Newton second per centimeter square, or sometime it will say poise. Poise is actually it's a CGS system. Poise, they will say poise or dyne second per centimeter square. Dyne second per centimeter square, like this. Okay, poise, all are viscosity related unit. Now the last topic is regarding surface tension. Surface tension, nothing, it's a different type is instrument used is capillary. Different method to find out surface tension is capillary tube method 1, drop weight method second, drop weight method, and the third one is stalagmometer. This is important in some of the options in the questions. I saw this name stalagmometer. You had to by heart this one, stalagmometer. Then last one is tensiometer. In the name itself it's there, tension is there. So surface tension, tensiometer. These are the different methods to find out surface tension, tensiometer. So the unit also it will ask maybe for the unit of this one is dyne per centimeter. Dyne per centimeter, or Newton per centimeter. That's depend upon SI and CGS unit. So SI unit is here for the viscosity Newton second per centimeter, but in case of surface tension SI unit is Newton per centimeter. Newton per centimeter. This is SI unit, this is CGS system. Okay, hope all this clear. Thank you for watching this video. And if you like this video, please make a thumbs up and also share with your pharmacy friends. If you are watching this video first of all, means the first time until now, if you didn't subscribe to my channel, please subscribe, press the bell button also. Thank you.